What is going on? It is time for episode 13. That means a continuation of building our website, building out our API, and making things happen in a real-world scenario. So, what I got planned for today is we're going to do a little bit of review on the website just so we understand how we got to where we are. And then we're going to have our website get data from our API. So, without further delay, let's get it on. Okay, we're going to start by going through a little bit of review on our website, and we'll do the same with our API once we get back to it and actually start making some real changes. There won't be any change to the API code today, but we will have some changes for the website to make it get its data from our API project instead of the way it's hard-coded now. So let's jump into it. The first thing we're going to do is we're going to jump over to our GitHub site and we're going to clone the code. So we'll go into github.com/noblecausecode, which I already have up here. If you need more details on setting this up or using Git to get the code, go ahead and click on the card above, and there's a whole episode on how to get that set up, a little video short. So we're going to go into the UI repo. And inside code, I'm going to choose SSH because I have that set up, but you probably are going to want the HTTPS. So for me, I'll click SSH and copy. You'll do HTTPS. So I'm going to go into Git extensions, clone repository. I will paste it into the repository to clone. My destination I have set up as episode 13. I have empty directories inside Savage Cell. I have an API and a UI. We're doing the UI now, and MVC. There's nothing in there right now. I'm going to clone the latest code. So I've already pushed up the code for episode 13 here because I already recorded this episode once. I was not happy with the quality, so I'm redoing it. So we'll ignore this episode 13. It already has the code for the end of this episode. So we'll leave that. It's fine. But I'm going to start off with where we left off on episode 12 by creating a branch here. And I'm just going to call it episode 13 start. And so now I have a branch that's the same as episode 12. And so if I open that web project up, we will be ready to go. And while we're at it, I will open up another Visual Studio and we'll go ahead and clone the API code as well. So if we go back to github.com/noblecausecode, we can go into the API. I will copy the SSH path, you grab the HTTPS path, and I will clone that repository and put it where it belongs inside API. And so API, that looks good, clone, and that one we can leave where it is. I'm not going to switch to that right now. We will stay on the UI project, but I will go ahead and open this on my other monitor so that we can refer to it later. Okay, so here we are where we left off with episode 12. So let's take a quick look through our code and see how we got here and debug it a little bit so that you understand the flow. Everything starts in program CS, and eventually it's going to call our startup class because of this use startup. Kind of built-in plumbing. I didn't write any of this code. The startup class has some methods that get called like configure services and configure. We've added 2 lines of code here. The first line of code sets up dependency injection with our product service. What this means is anytime that .NET is creating classes for us under dependency injection, if it sees an iProduct service needed in a class constructor, that it will create a product service class and it will inject that instance into that constructor. That happens in our home controller. Our home controller has a constructor, and one of the things it needs is an iProduct service. So when dependency injection sees that, and it sees that because of this line where we add controllers with views, this sets up all of our controllers with dependency injection. So before it creates the home controller, it looks in here to see if it needs any dependencies. It has two. It has an iLogger and an iProduct service. The iLogger is handled by built-in code, and the iProduct service is something that we created. So the iProduct service will inject a product service class instance. So it will do the new product service for us. Same thing with the iProducts repository. Anywhere that it sees that in a constructor, it will create an instance of products repository, and it will send it in and inject it for us. It just so happens that our home controller needs one of these services, and the service needs one of these repositories. We don't have to worry about telling it where these things are needed. Dependency injection will find them and inject what it needs. So if we looked at the product service, like I said, its constructor has a products repository in it. So it will create a new one and pass it in. Once it passes it in, we just assign it to a field in the class, just a variable, because we're going to use it later when we make calls when getProducts is called. But let's not get ahead of ourselves. The next thing that happens are all these other things are loaded, but the last thing that happens here is we map controller routes. And all this says is when we launch a browser, if we go to our site /something/something, it will treat it as controller/action. So if we go to /home, it'll look in the home controller. If we go to /home/index, it'll look at the home controller and the index method, and it'll run the code that's in here. If we don't specify a path and we just go to the base URL, it will default home and index as a default. So I'm going to go ahead and start this, and I'm going to put a breakpoint on this use endpoints. I'm also going to put some breakpoints in the home controller, in the constructor, and I'm going to put one on line 23 inside index. I'm going to put one on the return view on line 33. I'm going to go into the service. I'm going to go and put one inside getProducts. And then in the repository, I'm going to put one inside getProducts on line 10. All right, so those are just places where we're going to stop. So let's restart this. And the first thing that happens is we pop a browser and we're going to localhost with a port. Don't worry if your port's different than mine, that's fine. The point here is we do not have anything after localhost. There is no /home/index. So /home/index is assumed because they are put here as the two defaults. So we're going to let it go and hit continue. So the first thing that happens is, because we're making a call to our home controller, dependency injection says, well, before we can create a home controller needs this iProduct service passed in, so I better create that first. So it calls iProduct service and it passes in the repository that it needs. We populate that variable so that we can use it later. Now I'm going to let it go. So now it can create a product service, and that product service has the products repository in it. And we assign the service to a variable inside our controller. Next thing that happens is index gets called because our browser made a request. Inside our index method, we're calling product service.getProducts, and we're assigning the result to a products property inside our home view model. right after we create our home view model, we're going to call this method and assign it to products. So that's where we're going to go next. If I step in, you see we're inside get products in our service. Well, the service, which already has our repository instance from before, it's going to call that and call get products in our repo. All that does is create an empty list of products. It adds it adds 2 things to the list. The 9 things are in our API. This one we only did 2. And you can see our list of products has 2 items in it, and it has ID 1 and it has ID 2. Those are the 2 that we just loaded in there. And it returns that to our get products in our service layer, and that returns back to our view model variable dot products, and there are our 2 products inside the products property of our view model. Now we're taking that view model that contains a products property with the 2 items, and we're sending it into our view. If we look at our view, sorry, I should have made that bigger. Boom. So hopefully you could see that up to here. And then the view with our home index, what it does is it receives, this controller is sending our view model into our view. So in our view, we just tell it, hey, you're going to get a model from the controller, and it's going to be of type home view model, which we know has a products property. So here in our for each loop, I tell it to go through each product in the model.products. So the first time, this will be ID 1. The second time through this loop, this will be ID 2. And for each one, when it goes through this loop, when it's ID 1, we'll set the image, the title, the price, and the location. And then we'll go to the second item and set its image, title, price, and location. And we'll output this card for each one. And we can actually see that. I think I needed to put a breakpoint here. Let's see if we can still catch it. Yes. So our model.products here has our 2 items that was returned to us, ID 1 and ID 2. And product, this time, this variable is just ID 1. So it has its description, image, location, that kind of stuff. And so it just goes through and it outputs the HTML with the right dynamic data from our product. The second time through our list, now product is ID 2, and it has its properties. And so we just read those out one at a time for that one, and then we're done. So we see the 2 products. And that's it. Hopefully that was really easy to follow. I know some of the dependency injection stuff's a little bit confusing, but hopefully that cleared it up a little bit. And if it didn't, just keep working with it, and you will see this pattern gets repeated over and over and over, so you'll get really comfortable with it. So for now, I'm going to go under debug and delete all breakpoints just to get rid of them all. Yes, I'm sure. And let's go into this product repository and let's replace this code here with some actual code to call our API. So first thing we have to do is talk about asynchronous processing. Right now, everything that we have in this project runs synchronously, which means one at a time. Line 14 does not run until line 12 is done. And the products.add doesn't happen until we create this new product inside. And in our home controller, the constructor runs and then we create this model. The model doesn't get created until get products is done. So we're step by step synchronously. In order to call out in our repository to our API, we want that to happen asynchronously, meaning that we don't want to tie up the web server while we wait for a reply for our API. Computers are really fast and they're very efficient at doing things. So why tie up this thread that's running all of this code when we can kind of make our call to the API and then say to the server, hey, you go do what you want with this process. We don't need it right now. We're waiting for a response anyway. When we're done and we get a reply back from our API, then we need control back and then we'll continue. So what we actually need to do is we need to run our code, but then we need to return out of our method. And we need to return all the way back up. So if we're making a call starting at the home controller that calls get products, and that product service calls the repositories get products, when the repository goes out here and calls our API instead of doing this, what we want to do is return back something all the way back to the controller saying, hey, we're good right now. You can go do your thing and just let us continue from where we left off when we're ready to continue. So .NET gives us a system of async await and returns an object called a task. And the task is aware of the asynchronous things going on, and it knows how to pick up from where it left off. So while we don't have to write any of the code specifically to do the asynchronous work, we do need to set up our methods so that .NET can run our code asynchronously and use those threads of operation while we're waiting. So the first thing we're going to do is we're going to make this method asynchronous. We do that with the async keyword. And then we can't just return a list of product because we won't have that until our API is done, right? We have to wait for our API call to be finished. So we need to return that task that I mentioned. So a task will take a generic type inside it, which means we can define whatever type we want. And so we're just going to say, hey, this task can hold a list of product, but it may not have a list of product in it if we're not done yet. So we'll bring in the namespace of system.threading.tasks, right? That added this guy up here. And now our interface is complaining to us because, wait, this is supposed to be a contract. The repository interface dictates that we must have a method called getProducts, and it has to return a list of product. Well, it doesn't anymore. We just changed it to a task of list of product. So because we know this is the correct thing we need now, let's go update our interface with task of list of product. And we also need to bring in the namespace here. So now our repository is all set up. And the only thing we get is a warning saying, hey, you said you were going to async await something and you put async, but you never put await. So it's just telling you this async method lacks the word await and will run synchronously. So it's just kind of a friendly reminder, like, I think you did something wrong because you told me you were going to await something, but you're not. We're okay because we're not there yet. So I'm going to comment this code out. Control K, Control C, by the way. And we're going to put in some code to call our API. I'm going to show you two different ways to do this, and we'll talk about why you would choose one over the other, and you can make your own decisions on which way you want to do it. So the first thing we're going to do is I'm going to go ahead and grab our API project, and let's run it again and fire up Postman so that we can kind of remember where we were. Okay. So we have our Swagger page that came up with our documentation. That's cool. And our API has our products controller. And we're going to call the products get with Postman. So I still have that from last time. And I'm going to hit send. And we get back our array of objects. And there's 9 of them here. So we'll know that we're getting our API data if we get 9 objects back in an array. And also notice we got a status 200 OK, and we called a get, and we called this address. So I'm going to copy this address for now. And let's go into our UI code, and let's call the API from our repository. So first, let's create an HTTP client. This is a .NET type. That lives in the namespace system.net.http. And its job is to make HTTP client calls, which is kind of what Postman's doing, right? We're recreating this Postman call with the status and the response and all that. We're just kind of creating that in code. So we have our HTTP client. We expect back a list of products, and we're going to call HTTP client dot. In the list of IntelliSense here, you can see that we can get things async, we can get streams or strings async, and we could do that and then convert all the code that we read out into JSON and then convert that and deserialize it into a products list, but that's a lot of manual work. Microsoft realized that, and they gave us some extensions that we can work with that make life easier. So we're going to use those. So I'm going to add a using statement for system.net.http.json. And so now once we add that and it's in scope, when we hit this, notice we have a bunch of different things that we can call now. So I want to actually call the get from JSON async, and I want the generic one, not this one. I want the one with the little brackets on it. Because what we can do is we can tell this thing, hey, go out to my API. It's going to return you some JSON, and it's already in the correct format to be a list of product. When you get this JSON from the API, go ahead and create me a list of product and do all that deserialization, like build it for me. It already matches. I know that because I made it. Right? And the structure here is the same properties that are in a product object inside my models folder. This product has the same properties. So it's no problem for it to turn that in. The error that it's underlined here is just because we haven't fulfilled all of the arguments. So it says that no overload takes 0 arguments. And if you look at the help here, if you can read it, it's missing a string, which is the request URI. Well, that is the path. Let's put it in quotes. And I'm just going to put an enter on here because our font's pretty big, so it's kind of hard to see. Let me shrink this down a little bit. All right, there we go. So call this URL for products, and when you get the JSON back, turn it into a list of product and store it in this products variable for me. And then I just want to return that variable, right? The reason we have an error is we set this whole thing up, remember, as async, and we told it we were going to await a call. We were going to tell MVC, hey, we're done for now. You do your thing, and I'll let you know when I'm done. But we never use that await. We still have that warning here. So if you look at what products actually is right now, the data type is a task of list of product. Well, I don't want a task of list of product. I want a list of product like I told it to. But because this is an async awaitable method call, we have to put, before we make the call, the word await. That is enough syntax between the async, the task, and the await is enough to make this thing work where it makes the call, and now it's going to return back the task. And then when it's done with its call, it will return back to line 16, assign the variable, and then actually return products instead of just the task. Now that brings up an issue. And the issue is that we did this for the repository, but now we're going to try and return a task, right? When it's not done yet. It's going to return a task back to the service, and the service doesn't know about tasks because the service is looking for a list of product back. And that's why if you see this error, it says it can't convert a task of list of product to a regular list of product that it's expecting. And if we didn't see that, right, we were here, if we would have tried to build, it'll give you a build error now saying the same error, and if you double click the error, it'll take you to the line that's a problem. So all we have to do here is the same thing that we did here. We have to mark it async with a task, and then it'll know what to expect. So I'm going to make it async until sometimes you'll get back a task. And I'll bring in the namespace. And then I also have to update the service interface because now it doesn't match. It's still set to list of product. So we'll copy the return type in there and bring in the using. And now we're almost good. But remember, when we have async, we need to have a what? An await. And so now we're good. And we need to do the same thing back in the controller. We need to take whatever this is. We need to make it async. And we need to add a task to its return type. And bring in the namespace for task. And we need to await the call. Same thing. It's the same pattern. And that's it. So now, let's go into our repository. We will put a breakpoint here. I'm also going to put a breakpoint on line 19. And so we get to this call where we're about to call out. We create our HTTP client. We make the call. And when it's done, it brings back 9 products from our API. Your API has to be running, by the way, for this to work. So if you're following along here, make sure that you've already run your API project. Let's crank that one up too. Let's make sure you're already running your API project and you have your Swagger page open for it just to show that it's running. And so now we called out to our API. We got our 9 items back, 0 through 8. And we're going to return those the same way we returned back. And we'll pass those to the view. And this time in the view, it'll go through that loop 9 times. And you'll see that we get our 9 items. Now, they're not laid out exactly right. They're not going across the page nice. But we'll fix that. But we are getting them back from our API. Still hard-coded. We need to add some database stuff to that and make it a little more dynamic. But we have done a full round trip from our website over to our API and back. All right, let's enhance things a little bit. I'm going to stop the UI project. In our repository, I'm going to delete this old code that was hard-coded there. Okay, and I don't really need this variable products because all I'm doing is I'm making this HTTP call. I'm assigning it to a variable, and then I'm just doing a return with the variable. I'm not doing anything with the variable itself other than returning it. So I really could just get rid of var products equals and just say return whatever the result is of that, and I don't need to create a variable for it. Now, if I needed to do something with that list before I returned it, then I could use the variable, but I really don't have that need. So, some things you could do with the HTTP client. You could inject the HTTP client. And if we were going to use that in multiple repositories or use it over and over again, it would be a good idea to inject that rather than creating a new one every time we needed to make a call, because we're calling the same endpoint really every time anyway. So why keep creating and destroying the client every time? It's a little bit of overhead we could avoid, make our code a little more efficient. Another thing we can do is we can replace and not use the HTTP client at all and use a third-party HTTP client. I like one called Flurl. And the reason I like it is it has what's called a fluent API. And I think it's a little more clear, and I think it's easier to use, especially if you look at Postman. When you go to things like a post, you then have things like a post body where you're going to be passing raw JSON to. Think about if you're signing up for a website, you would be passing, JSON data with your login and your password, right? I mean, so you have a body that you need to pass. And then in addition to that, there's headers that we can add, things for authorization where we can put API tokens and things like that. So we start getting into a lot more code that we'd have to create with our HTTP client. It's not just create it and one line of code gets it. You have to set the headers. You have to set the post body. Sometimes you have to convert your post body from an object into JSON. So we want to use what is best for us, what's easiest for us. This is fine. There's nothing wrong with this. It's very efficient, great code, but I just prefer the syntax of Flurl, and it's a very lightweight wrapper around this same HTTP client. It doesn't add much overhead, and I think it is easier to understand. So I'm going to show you how I would do this with Flurl. So we're going to right-click dependencies, manage NuGet packages, and once that pops up, we'll go to Browse, and I'll search Flurl, F-L-U-R-L, in case that's too small for you to read. And we're going to install the Flurl and flurl.http. So first Flurl install. Don't show me that again. Okay. And that's good. And now we're going to do flurl.http. And we're good. So if you look under dependencies now inside packages, you can see it installed those two DLLs that we need, or those two packages. All right. So now we're going to basically duplicate this code. So I'm going to Control KC and comment that out, and we're going to do the same thing with Flurl. Just to make things easier, I'm going to add the usings for Flurl manually. And that's just because I want to show you all of the IntelliSense that comes with it. So the first thing that Flurl gives us is something we haven't talked about called extension methods, and it does this on the string class. What an extension method does is it adds to something that's already there. So normally with a string, like if I get rid of these two temporarily and I just make a hard-coded string and I put dot, all I've got are the normal string classes, like, or the string methods like length and trim and contains, but there's not anything that has to do with calling APIs and calling, you know, like get JSON type things on a string. So Flurl extends string and adds some of that stuff in. So now if I take a string, and I'm going to use our endpoint, and now if I hit dot, I can actually call some of these get JSON type things. So the first thing I'm going to do, and I'll start it on one line, but I'll probably end up moving it to the next line, is I'm going to do something called append path segment. And in there, I'm going to put a string. So I'm going to remove /API products, and I'm going to put that inside append path string. That to me makes a little more sense. What I'm saying is call this host, this domain name, like Jeff's API. In this case, it's localhost. And now I want to actually call the endpoint /API/products. That's the one I want. And so this code will always be the same, and we can end up injecting Flurl with this already in it. And then we'll just name the endpoint that we want at that host, because all my endpoints are going to be in that API project. So they all have the same host anyway. And then I'm just going to call get JSON async. And it's the same deal like the other one, where I can just tell it that I want a list of product. And I can assign that to a variable the same way we did before. And I also, because this is an async return, this is also awaitable, and so we would await that. And then I would return products. So again, I don't need to do that, right? I can just return this call. So to me, this is a little more like English to read for me than creating a new client and calling get from JSON async with the URL as a parameter. Like, to me, this just says go here, then specifically call this endpoint and get me my list of product as a HTTP get and return that. And that works exactly the same way. And there's my 9 products. That's interesting. Okay. My mouse took off on me by itself and scrolled to the bottom of the page. I guess it wanted you to see that twice. All right, I think that brings us to a good stopping point. Today we went over how things work in our website and our MVC site. We learned about the async await programming pattern with tasks and how to retrofit a non-async method and convert it into an async method. We learned how to call our API instead of hard coding from our website and how to display those products on our web page. So good stuff. We actually have a full round trip going from our website to our API and back with data. That's big stuff. So yes, we need to retrofit our API with some database information instead of hard coding those 9 products back. Next time, what I want to do is I want to get back into our API and I want to add an individual get product by ID kind of a method in there, an endpoint for our API, so that we can click on an individual item and we can see the detail of that item. So then we'll have 2 endpoints from our API. And once we have that, then maybe we'll add some database stuff. And we still need to make our site look a little better. And we still need to add some of the search bar filtering type stuff to it so that we can get that level of functionality. So I think really good stuff. I think we covered a lot today. And hopefully you see some patterns emerging where you're going to be able to do these things over and over and build out all the features that we need of a website. And if there's anything you don't understand, please let me know. You can reach out to me on social media. I will put some of those links in the description, or you can comment on these videos. I try to answer every comment. And if you think this was helpful, please subscribe. I would appreciate it. It kind of shows me the love that we're doing something that you're enjoying. So until next time, practice, practice, practice as always. And you know where I'll see you. I'll see you online.